So suppose I have a ball here, and I move this ball. I move this ball by a certain distance here. To see how we can add vectors, suppose I have a ball, and we imagine moving this ball by a certain distance. Let's say, let's say 5 centimeters. So we move it in a certain direction, and then the ball comes here. Okay. Let me draw a ball there, and after that, let me move it in a different direction, say this way, this direction. I want to move it by, let's say 3 centimeters. Alright, so now it has moved 3 centimeters. Now if I want to add, if I just want to add distance, is just a matter of adding the two numbers. If I want to find the total distance traveled, I just have to add 5 and 3 in the, as we always do, and get 8 centimeters. And so 8 centimeters is the total distance traveled. But what about the displacement? What about the displacement? Displacement. Now let's think back at the meaning of displacement. Now, displacement, as I've described it before, contains two information. It contains the length information, like say this first displacement here, as well as the direction information. So in that sense, this direction is different from that direction. All right. And this leads to a different way that we should interpret the adding of these two displacements. That means that we shouldn't just add the two lengths. We shouldn't just do 5 plus 3 is equal to 8. Right? Now, the reason why we shouldn't do that is because if we do that, what about the direction? Okay, in this case, we have a direction here of 5 centimeters. Let's say from along here. Let me make it clear. Let's say a direction along here of 5 centimeters and a direction of along here of 3 centimeters. Now, it's easy just to add the length, but what does it mean to add the direction? I can, for example, say add the angles between of each of these lines, but that's not very meaningful. So this leads to a new way of thinking about adding these two vectors, and that new way is to say that, right, now if I add this displacement to this displacement, I should think about the results, all right, the result of this addition. Since if we are talking about displacement, we have just displaced this ball from here to there, and then we are displacing it from there to there. Now, if you go back to the start, all right, and look straight at the final position of the ball, right, relative to the starting position, we can draw. Okay, I can draw an arrow going from the starting straight to the final position, and that logically is the resultant displacement. All right, it's the final effects of displacing a ball this way and then that way. The final effect is an overall displacement of this way. So because of this logic, the addition of two vectors is defined in this way. It's defined, we can think of it as being defined by geometry. And one way to think of it is simply by drawing this triangle, right? If you have one vector that you want to add to the other vector, just draw this triangle, and the third side of the triangle gives us the answer. So in what sense does it give us the answer? Well, if you actually draw 5 cm here and 3 cm here at the correct angle, then you can even do this on paper with a pencil and a protractor and a ruler. Then this line here, all right, you can join this line with a ruler and measure its distance. And then you can also, let's see what else you can do. You can also, if you think about a certain reference direction, say again this direction, we can also think about finding this angle. All right, you can take a protractor, for example, to measure this angle, and this angle, say 10 degrees or whatever, will tell us the direction of this final arrow. So in this way, we would have obtained an answer for the addition of these two vectors. So that's how we can do it. So, and to actually in practice, it might seem a bit troublesome. You have to find a piece of paper, a ruler, and draw this. So that's how it is. And there are other ways to make it simpler. But for a start, let's use this idea to motivate, to teach us how we should treat other types of vectors as well. So in this case, let's say my displacement here. Okay, I have a displacement here. Now, I can think of, say, the distance addition is just 5 plus 3. But mathematically, how should I write down the adding of two displacement vectors? So let me, let's say, think about representing this arrow. Now, it's easier if we use a little bit of algebra. So let me call this arrow here, let's say A, with an arrow on top. So that's one way to represent a vector. Okay, and I can call the 3 cm vector B with an arrow on top. So using these symbols A and B, I can say that I would add the two displacement A plus B. Okay, and then I can say that the answer. Now I'm going to call this answer vector. I'll call this C with an arrow on top. So this would be the resultant displacement of adding A and B would be C. Now that looks a little bit abstract, and it is. The idea is that when we read this equation, all right, it's not just algebra of simple numbers. It's we are actually adding two ideas together, and not just two numbers like 5 plus 3. Right? The first idea is A, which is a length and a direction. The second idea is B, which is another length and direction. And the rule of adding them is not just the rule of adding two numbers, but it actually requires, for example, the drawing of this picture and the triangle, and maybe using a protractor to actually measure this answer. So it is a kind of a troublesome way. It's a lot more hassle than just adding two numbers. That's kind of expected, because after all, vectors has more information than just the two numbers, than just 5 and 3. So for example, if we start with these two original 5 cm and 3 cm displacement, then after finding the final answer, say by drawing this triangle, let's say after finding the final answer, we find that okay, let's see, let me give an example of what we might get here. Let's say the length of C is 6 centimeters, okay, and let's say it is at an angle of 10 degrees. Okay, let's say it's at an angle of 10 degrees to the x-axis, to this horizontal axis. So this is how one way to describe a vector, right? Its length by stating its length and its direction from as an angle from some reference axis. So therefore, after although we have a rather abstract equation here, A arrow plus B arrow equals to C arrow, the idea is that using this calculation method, the final answer, we think of the final answer as being written by C with an arrow, but we can actually write down, describe the information contained in C. Okay, I can say that this down. I can see that C, okay, C is actually equal to, okay, is actually equal to, well, equal might not be, let's see, let me put this another way. I'll just write below, I'll just say C with an arrow is, I'm going to describe it. Alright, C is 6 centimeters and 10 degrees. 10 degrees to the x-axis, right, which is that one there. Okay, so I've just described C quite precisely, all right, from what I measure, for example, by drawing this triangle. So that's how we can add the two vectors together. And this idea here also provides us with the rule of adding all other types of vectors.